Okay, so problem number 132, Palindrome Partitioning II. Given a string S, partition S such that every substring of the partition is a palindrome. Okay, what is a palindrome? It is a string that reads the same forward and backward. Return the minimum cuts needed for a palindrome partitioning of S. Okay. Okay, so every substring, like every partition, should be a palindrome. Okay. So, the first thing that I want to ask is whether can the string S be an empty string? Okay, no. So it will be at least like A, and the minimum cuts needed will be 0, I think. Yeah. Okay, so okay, so for A, B, it will be coded 1. And AAB will be 2. Okay. So it seems like if we look at the last character, is it always like letters? Yeah, okay, lowercase English letters only. So when we look at the last character, like here, okay, so if we have a partition here, and then the problem, okay, so if the last element, like the last character, is a palindrome, then the problem will be try to find every substring of the partition, trying to find palindrome partitions in the rest of the substring. Okay, yeah, so it's like the problem is shrinking, and so, yeah, and it is the same problem. So it can be a dynamic programming problem. I think I would like to first go for a deep depth first search approach, like a recursion approach. Then yeah, I think it will be easier for me to think. So if I have like DFS, so I will have DFSI. It stands like the it will be the minimum, the min cuts. Let's see if it's if the definition works. So the minimum cuts needed for a palindrome partitioning of S of substring S from 0 to I. I would say if the length okay, so DFSI, like the equation will be DFSI like the problem will shrink from I to I minus 1, since we will only need to find find a palindrome partitioning in the substring S to S0 to S I minus 1. Like okay, here is the substring from index S to index I minus 1. Okay, let's stay for this definition of DFSI, and then it will be if try to find the minimum cuts needed here if the partition, the left partition, the right partition, like the left side will be the rest of the array, the substring, and the left side will be the right side will be if Si minus 1 to I is a palindrome. Yeah, and this will be one partition. So we need to find the minimum cuts, like this will be 1 plus 1, because here it is 1 cut, and we will see how much is it, how many cuts here in the rest of the subarray. Then we will also need to find, like, if we make a cut, like if we make another, we don't make at the end of the string, we make it here, like how many cuts does it need? Okay. So if we don't, like, we need to find the minimum cuts, and yeah, like this one is, if we made a cut here, and if we want to make like this cut or like this cut, so yeah, we need to find out how many cuts do they need. So this will be I minus 2 plus 1 as well, since we only made one cut, and this will be I minus 2 till I, if this is a palindrome. Okay, so we'll have to find these for a minimum, and this will be like till, I think, like the whole thing is a palindrome, like the whole string S is a palindrome, then it will be 0 till I is a palindrome, and here it will be 0 as well. Yeah, it will be an empty substring. So yeah, then so the boundaries will be, if I is 0, then oh, but here we don't have a party. We will not make a partition here. So if DFS I is 0, then it will be 0. So return 0. And this time complexity will be O and with the power of 2. Yeah, okay. Let's begin with the implementation. So I will have like the let's first have the length of string will be stored in an constant, and the function will be DFS. Parameter will be I, which is an int, and then if I is 0, then return, let's have the boundaries, then return 0. Then else, if we are not at the boundary, then we will loop through the start index. Like, see, yeah, we will loop through the start index of the palindrome. So for J in range, it will be starting from I minus 1 and ended at 1. Is it 1? No, 0. Since let's keep it, but this will be step will be -1. So it will be like if okay, we'll have a min here, like min cut, and it will be let's have like if okay, length will be 2000, then we will have 2000. Oh, let's have the length like and -1. Yeah, like every single character it will be a palindrome. So the most like the largest cut, the largest count of cut will be n-1. And so if like if sj till I is a palindrome, how can we do for the palindrome? How can we like if we reverse the string, then let's have it. I'll first write like reversed, then no, oh sorry, yeah, since palindrome, the definition of the palindrome is a string that reads the same forward and backward. Okay, so if this is equal, then it will be a palindrome, and okay, then we will count min or dfsj. Then at the end we will return the minimum cut of dfsi. Yeah, and for the whole problem we will return dfsn. Yeah, since the since dfsi's definition is the minimum cuts for a string that is from index 0 to index I-1. So we will have n to have index 0 to index n-1. And yeah, we haven't done to the range end. Let's see, this is I-1, so till yeah, we want this one to be 0, so it will enter here and then have 0. Oh, we have 2 plus 1. So yeah, we don't want the DFS 0 to be in this So this should be at this 1. Then if this is 1, yeah, I cannot make it like really smooth, like yeah, if this is partition 1 and this will be 0, so 0 plus 1. No, this is 1. Yeah, like the start index of the palindrome, and DFSI stands for the minimum cuts needed. Like I wanted to loop through to have 0 here, but if I have 0, then this plus 1 cannot be added. Okay, if like I think we have to dry run first. It seems like yeah, some boundary problems. Okay, let's have A first. So for A, the n will be 1, and then so yeah, if 1 equals no. How about we have like no? I don't think that's a good. Is it a good idea? Like minimum cuts needed for like substring 0 to 0. Okay, let's forget it. We'll have, okay, we'll just dry run this one. So n is 1, and then it will not run into this return thing. We will have minimum cut 0, and for j and range 0. Minus 1. So for range starting from 0, if 0 till 0 is it will be equal, then minimum cut will be this is 0, yeah, 0 with DFS 0 plus 1. Okay, we will have DFS 0. so it is 0 as well, then you will have 0. Yeah, no problem. So let's see A and B. This one, it will be 2 for N. So 2 minimum cut is 1. For J in range 1, starting from 1. So J is 1 now. And I is 2. If it is equal, okay, it is not 1 to 2, so it is B. Yeah. Is it equal? Yeah. So minimum cut is 1, and div is 1. What is okay? So we have to calculate div as 1. Div as 1 is div as 1 will be a range starting from 0, and if 0 to 1, okay, so it's A. If A is a palindrome, yes it is. Minimum cut is 1, and I don't think this is a good idea. I think it will be better if like I minus minus 1. Okay, we have A. Oh, I forgot where we are now. Oh, we have A is equal, so I think J is 0, I is 1. Yeah, I is 1, and J will be 0, so it is 0. Minimum cut is 0 as well. So yeah, 0, then we will return, and before it is like how much? Oh, I is 2 and J is 1. Yeah, J is 1, I is 2, and this is 0 plus 1. So minimum cut is 1 for DFS2. No, we haven't finished it. This is like 2. This is 1, and we have 0. For 0, it's 0 again. So yeah, correct. Let's run this testing first. Oh yeah, we forgot. Okay, let's maybe check like Python string first. Okay, so Python string reverse, it will be 2 columns with and -1. Okay, then we will have Okay, it's a bit we'll have partition here, and part is equal to part reversed. Yeah, let's have a catch, since it is like calculating the same df as I, so okay, things okay. We will turn this recursion to for loops. So for first thing, we will have we will have an array to memorize the previous cut we have calculated before. So yeah, we will have min cut, and the default value will be 0. No, we will have n minus 1. Then I think we will have let's have n plus 1. Yeah, since we want the last value to be min cut n, so we will have n plus 1 number of lengths of the array. So for I in range n plus 1, should we start it from, no, okay, yeah, I'm thinking should we start it from 1, but I don't think so, since we have we can have it like this. Then we can start it from 1. And then for j, yeah, let's copy. Like min cut. Can I write like one line code? I'm not sure. Like min cut I will be if okay, not that, yeah, not that easy. So I will leave like a nested for loop, and yeah, I will have partition is s substring s j index j to index I. If this is a palindrome. Then we will have min cut equals min. No, we'll have this line with TFS. No, with J plus 1 if yeah, like this, and return min cut n. Okay, seems good. So far so good. Alright.